Okay, in this video I'm going to talk about my top 5 favorite scablands. This includes Argentina, Canada, Russia / Uzbekistan. We've got Australia, of course, and Oregon. Those are my favorites, not necessarily in that order. Oregon's got to be up there. I really like Oregon. But let's start with Argentina. And let's start zooming out just to get the big picture first. So as far as the continent goes, we've got a ridge here, which was uplifted due to tectonic forces. And then how it was eroded away is due to erosional forces. Most people would, say that glaciers carved out all of these features here, but if you study them carefully, you see that there's ripples and all sorts of detailed scours that is not consistent with glaciers, especially because they're filled with salt. Another reason is if you look at the banks of this channel, right? If this was a water channel, it would be consistent to see parallel rivers running all the way up onto this channel, and that's what you find. This is and then over here we got it's a little bit more like terraces, kind of like drumlins too. It's hard to see. But there's no moraines here. No lateral moraines, no terminal moraines. And then, so yeah, this is clearly from the ocean washing over this piece here, as well as this 30-mile wide channel that came through here. Can't have been the glacier because the glacier wouldn't have left behind all of this salt. It's only if it's right there next to the ocean. It's not that much of a stretch to understand that this was from water erosion of the ocean. This laminar flow being from sheet water flow. Now let's go to Canada. So if you study a geologic map and you understand the geology of this landscape, you understand that there used to be a seaway that went through here, an ancient seaway. And that's what the depositional record shows. Now let's look at the erosional record. And we see that this is a textbook area of Scablands, because you see ruts parallel and close ruts of a river. And then they're filled with salt, so that's thus making it a salt scablands area. Here we find, two nice, somewhat parallel, long lakes being river troughs. Here's another one. But this one is broken up into a bunch of sections. So how can we understand that? And what does that mean? And does that mean something incredibly catastrophic that will blow your mind? The answer is yes. Let me explain that by taking you back to Russia. Okay, so this is Russia. First, you understand sheet water flow, parallel lines, laminar flow, blah, 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 right? You've got the parallel forms being drumlins, and you've got perpendicular forms being ripples, right? For example, right here, these would be, you can see that these are ripples being perpendicular to the laminar flow being parallel. Okay, covered the groundwork. Now, we also see that this is very scabbed up, right? All of these are scours, right? What eroded out that scoured landscape, right? Water erosion is strongly suggested by this massive feature here being, let's check it, 340 miles wide. So this is giving us direct evidence of a 340-mile wide sheet water flow that washed through here like a massive current, and not a turbulent current, a very clean current, because it takes a low turbulent conditions to create this perfect laminar flow. Okay, plus all of these perfectly perpendicular ripples. There's a very clean sheet water flow. One of the best examples in the world. Now, I explained all that so that I can show you this spot here, which reminds us of Canada. Right, we see how we get these scours coming across. This is the same type of thing we find in Canada. Right, so how can we understand this? Well, if this is laminar flow, right, if there was a focused path of current, which is what laminar flow is, a specific one right here, and it even curved a little to make this. Maybe that happened later. But let's say there was a strong current that went right through here. And let's say the same thing happened here. Here we can see that these are perpendicular forms being massive ripples. Okay? And we can even see the front face of the ripple. Right? So this was the leeward end and this was the forward end. And then we can check wavelength, 2.6 miles. Obviously that's insane. But what that's showing is an undulating force of water current. So the water path went through here and it undulated just like a ripple undulates, creating troughs, a series of troughs. So that's exactly what happened here in Canada. Let me give you another example because I know you guys are skeptical, saying crazy stuff. So just bear with me. We can go to this beautiful formation right here, right, which fades into a thin channel. But this is a channel itself. Let's go to this side here. And we see the same thing, right? This would be a clear path of water. And then we can see that these lakes are then from the undulating force. Okay, let me give you an even better example. This is probably the best example in the world. No better example than this. So check this out. Fluvial sediment lobes on the bottom pushed forward by the current. That indicates the current went down this direction. Okay? It went this way. Or at least that's how the sediment lobes were formed, right? That doesn't mean the channel was formed that way. But at least the sediment lobes were formed that way. Now when we get over to this edge here, edge of the channel, we see that this also has a series of lakes, therefore from the undulating force, just like this. Okay? Just like what we find over here. So I hope that makes sense. And then if we go to a spot like this, where we can also see lakes in a line. Anytime you find lakes or scours in a line, they're organized for a reason, right? So what this is, you can see that this is the trough all the way across. This is a trough. This is a trough. That's showing a ripple pattern. So the undulating force is at the trough. That'd be saying an insanely wide or extremely massive ripple formation if that was how these lakes were excavated. Something had to remove the bedrock and the topsoil and a lot of it to make these lakes. So that is one theory that is possible with physics. You know, something like this. This is actually a great example because you can go right up here. See, oh, these are ripples, even perpendicular to the laminar flow. Textbook. perfectly perpendicular to the laminar flow. Okay, let's follow that, see if it can line up into the scabs. Oh, it does exactly. That's exactly what these are saying. This is the trough of the ripple. This is the trough. Okay, so this is, if you study Google Earth, if you go to anywhere on Google Earth, you're going to find scabs like this. Little lakes that are somewhat random, somewhat organized. But anytime you find a feature that looks like this, where you got long lakes and rounded lakes and square lakes and triangular shaped lakes, you're looking at a Scablands, right? If it's a really good spot, you might see some drumlins. And if you see ripples perpendicular to the drumlins, you know you're talking about sheet water flow. Okay, you go to Google Earth, you're going to find these anywhere and everywhere. Now, you know I love Australia because my profile picture is Sharks Bay, which is also a perfect example for what I'm talking about right now, the undulating force. Laminar flow went through here, perpendicular form being these ripple troughs, and then where it was focused, you get these here. Okay, you guys should be getting that. If you disagree, please let me know in the comments. But here you can see clearly the ocean current, carved this out, went through here. And that's why these lakes are salty. Okay? That makes sense. Salt Scablands, insane ocean current washed across here. Then you get salty lakes. Well, is that why this in Argentina is salty? Right? I mean, it's not that far from the ocean. Right? It washed down into the ocean clearly from this direction. And from over here, it went, over this ridge here, sliced it up real nice. Okay, but back to Australia. This is all salt Scablands, this entire continent. All of these spots are salt Scablands. And if you maybe check out this spot, you'll see that these paths are from river channels. They were like river channels, but it was the ocean. And so these channels went through, made these lakes. See how they're clear paths. All right, this is from the ocean current acting like a river. And you get all of these lakes. So that's what these scours are. Okay, so now we're going to check out this spot here. Parallel forms being the drumlins, perpendicular being ripples. But these ripples would be way too insane. Doesn't matter. It's physics. Just see what the physics says. That's how I think of it, There's no way it could be 12 miles. Well, it's physically possible that could be the undulating force perpendicular to the laminar flow that made these drumlins. Parallel ruts and drumlins. I mean, all the features are here. And then you've got, ravines running offshore, right? Connecting to salt scabland river channels. I mean, it's all there. It's, when you look at one location, you say, well, that's too insane. But then once you get an idea for how the entire Earth was created, it all fits perfectly with what we see on all the continents that have salt scablands, which is all of them. An honorable mention, I didn't put Africa in this, but, you can see river paths went through here, or channels. Then you've got drumlins cutting across here, sheet water flow washing across here. This being much smaller likely happened later. The basin's full of salt. You go over here, you find a big old scour full of salt, and then you find what would be lakes, long lakes, horizontal from one another, likely from the undulating force, and asymmetrically shaped. So the reason why this is asymmetrical is, look at this. This is a clean line. And this is thinner and much more random. This is the tail. The tail is elongated and the scarp edge is clean. That's just a little, right? Elongated tail, clean, rounded, and slightly straight scarp edge. That's a general rule, but it works pretty good. Nice tail here. So when we go over to this spot, you know, we can find a nice tail on this guy. Then we can know current direction, which is, it's important to know current direction because when you study the current directions, you find that, for example, this current direction lines up with these drumlins. You know, that's important because these are both correlating one another. This being excavated from a water current, this is lined up with the same current. That's cool. But another thing is when you study current directions, you will begin to understand that the current reversed in a lot of places and was quite chaotic. So yeah, that's Ethiopia, by the way, but I want to show you Oregon. Oregon, I don't know, this might be my favorite spot because it's so obvious. So you've got the Washington Basin here. Very clean line right along here. Could be a channel line, I don't know. Comes around and spits you out right here. Comes through here. Kind of, there's a clear erosion that shows this current coming through here. Going which direction? Maybe both. And then, of course, coming down. These channels showing a current coming down. So as far as this current that swept over through here, let's check that out. Right, this is here we've got a directional one, clear tail here. So that's showing a current going this way. And that somewhat lines up with these ruts. These ruts here, actually, this one's showing the way that this is streamlined around, kind of shows a current going this way. But all these ruts, so like I said, goes both directions. But these ruts are coming from the Washington Basin. Oops, and then they come down. They cut across. Here you can see these ruts. And then these ruts are kind of intersected by something that was eroded previously, which was the much larger channels coming around. These are like 7-10 mile wide channels. Right, this one's, here we see all this showing a direction coming across here. These channels are a little bit more southbound. You can find some nice ripples on the bank, right? Mega scale, of course. And so these parallel salty channels and all of their complex river terraces, they kind of remind me of Ethiopia, right next to the Red Sea, right? So this isn't, you know, the difference between being close to Washington, everybody's talking about, oh, the Laurentide ice sheet melted, oh my gosh, you know, maybe the ice sheet, you know, glaciers eroded these canyons as well, and then salt, you know, just from groundwater, from the rocks, blah, blah, blah. But when you find the exact same feature right here in Africa on the equator, right, this is the equator, that green line, right here on the equator, right next to the Red Sea, and you're telling me this doesn't look exactly like the Oregon Scablands? Right, parallel river scratches, all of these parallel canyons. They curve like canyons. They're going different directions on top of each other. Yeah, this looks exactly like Oregon. So you don't need to mention the Laurentide ice sheet to understand erosion. And then you go up here and you find that these are also, you know, show work of heavy erosion. My favorite ones are actually farther up here though. There's some really nice streamlined ones on the Egyptian side. Let's check these ones out. So here you can see the current direction. It was just charging down the Red Sea, and it streamlined its channel around this guy. Streamlined channel here. Streamlined channel here. All of these little guys are streamlined and cut out by the current. So yeah, the Red Sea used to have a lot of current. This is also, I don't know how, if any of this has to do with, you know, the layers of strata, but which I think to some degree it probably does, but it seems like there's some really cool triple streamline feature here. And then you zoom in more and you find it's all scoured out. Real salt scablands. Even underwater in salty water, it's still salt scablands. All right, let me know if you've got any questions or a video idea. Might just check it out. Let me know what you think. And I look forward to hearing you guys in the comments, and let me know what I should do next. All right, that concludes this video. Appreciate it.